Let's talk about reflecting quadratics. And first of all, I don't really define reflecting up there in that top paragraph. I just say reflecting functions across the x and the y axis are an important mathematical process that's going to be explored in this lesson, most specifically to parabolas, which are also called quadratics. And the thing about reflecting, as well as the shifting that we did in our previous lesson, is it applies to all of the different functions. So let's look and see if we can figure out something about the reflecting by graphing. And I think that no, I don't. I was going to say, I think that I have them already in here, but I'll delete them out. And when we start here, we're going to put in x squared. I'm going to put in the parent function of y equals x squared. And then our first problem, I believe, says, let's graph y equals negative x squared. So if we graph, the first one again, there's the parent function. So the blue is the parent function. The red is the function that we're just asked to graph. What happened? Well, what happened in this picture here, and we can draw it, is that this point stayed the same, but this one was here and here, and then I'm graphing the point 2, -4, and -2, -4. And then I'm also graphing 3, -9, and -3, -9. And I'll show you where those came from in a couple of minutes. You can look in your table feature if you are graphing along with me. But what we just graphed in red is that's the y equals the negative x squared. And hopefully what you notice about that is that the graph flips over the x-axis. And just a reminder for a couple of you who might need it, this is the x-axis. This is the y-axis. What we did is we flipped it over. So let's change that up. We'll leave our parent function in our first graph. But now, instead of negative x squared, we're going to put parentheses, negative x squared. And watch close here, because it'll be fast. And I hit graph. There's the blue. Look what happened. The red landed right on top of the blue. So what happened here is, one, we can't see. It says, what seems to be the transformation? Well, we don't see any change here. But there is one. We just can't see it. So now I wonder if we can look at a different graph. I know that this unit is specifically relating to quadratics, but let's look at a square root function, and we're going to be graphing square root functions eventually. So this is just a little preview here, and maybe this one can help us figure out what happens. So when we graph this next particular function here, go back to the y equals, let's clear out these two screens here, and we're going to type in the square root of x, and that's going to be the same picture as what's on your paper. And then we're going to graph a negative in front of the square root of x, looking at that problem, and negative the square root of x, and we graph. And you can look in your table if you need more specific points. But hopefully what you see is that we flipped this graph over the x-axis. In other words, what happens is that this point at the origin stays the same. The 1, 1 becomes becomes 1, -1. The 4, 2 becomes 4, -2. The 9, 3 becomes 9, -3. And this is the graph of y equals negative the square root of x. And it's the same idea. We could see it in the previous problem, we see it here. We say that it flips, but another word for flips is reflect. Flips or reflects over the x-axis. So you can probably guess now, even though we couldn't see it on the quadratics, you can probably guess what's going to happen when we go ahead and type in this next function. So I'm going to take out this one. I'm going to type in the square root of -x. And again, it's going to be pretty quick. But there's the picture. And in this particular case, what's going to happen here is we're going to have a point still 0, 0, -1, 1, -4, 2, -9, 3. That's the picture on your graph, and this is y equals the square root of -x. Well, what happened there? And what happens there is that we reflect, reflects over the y-axis. What we want to do is we want to take a look at what's causing us to reflect over the x-axis and what's causing us to reflect over the y-axis. So if we look down here at our table, when the negative is in front of the function, so the function negative f of x is a reflection over the x-axis, and when the negative is inside the function, so it's f of negative x, it is a reflection over the y-axis. So let's look back in our folders here for a minute. And yesterday we had the transformation chart. We filled in this much. So let's go to the next two. So again, with respect to our chart that we started already, once again, when there is a negative in front of f of x, or there's a negative in front of the x squared, we reflect over the x-axis. And keeping with the same theme as yesterday, the negative is outside the function. In contrast, when the negative is inside the function, f negative x, we're going to reflect over the y-axis. And again, I oftentimes refer to it as outside the function or inside the function on this one specifically. And again, the negative is inside. It's within f. It's f negative x. So flipping back to our previous notes, and flipping them over, again, I'm going to go from the perspective of not using a calculator. You may use a calculator But we're going to get to a point where we're not going to be allowed to use our calculator. And I'm hoping that by the time we get there, that you already know the patterns in the graph and it won't be too traumatic, if that's the right word. But we're going to state the vertex, just like we always do. State the vertex of each of the following parabolas, then list the transformations, don't abbreviate them, then sketch a graph of the transform function. Well, the first thing that it asks us is, what's the vertex? So, like usual here, we're going to change the sign on the number in the parentheses, and we're going to keep the sign on the one outside. And if we're really looking closely at that, what that means is that we're going to go left 3 and down 1. But I don't want to overlook the fact that there's a negative in front of the parentheses. When there's a negative in front of the parentheses, it's outside, and that's going to be the reflect over the x-axis. And it's a little bit tight of a space on your paper, but I hope you can fit it in. And we're going to start just like we did on our previous notes. We started by graphing the vertex, which is -3, -1. And you can't see this on the video, but for those of you who are here in class, we're reflecting over the x-axis. I'm taking my right hand and I'm flipping it over. Because that's really what has to happen first when we graph. So imagine, if you're watching the video, that we're flipping it over, flipping the graph over, and our pattern then isn't changing much. But because we're flipping it over, we're going to go from the vertex, from the point that's on our graph right now, and it's going to be every single time, it's going to be from this point, we're going to go one space to the right, and instead of going one up, we're going to go one down. And we're going from this point right here, we're going to go 2 spaces to the right. But instead of going 4 up, we're reflecting, so we're going to go 1, 2, 3, 4 down. And not only are we doing the right side of that graph, so not only are we going to the right, we can also go to the left. We're going to go 1 space to the left from that point that I highlighted in green, 1 space to the left and 1 down. And also from that point in green, we're going to go 2 spaces to the left and 1, 2, 3, 4 down. And underneath your graph, I know there's not a lot of space, but I think that you can fit it in a little bit. What's the domain of this function? Well, it's all real numbers. And I don't want us to forget that. Domain and range tend to be a difficult topic for us. The range on this particular graph, you have to ask yourself, do you have a high point? Do you have a low point on the graph? If you have a high point, it's that green, you can't see the green very much anymore, but it's the green point. And when you're looking at the range, you're going from the lowest value, which is negative infinity, to the highest value. It's going to be the y value of our green point, which is -1. It's going to have a bracket around it. Just a little bit of an extra piece there, just to keep that fresh in our minds of what we're doing with these particular graphs. But let's try another one. Letter B, y equals, in parentheses, -x squared plus 4. The vertex of this particular problem is 0. There's no number beside the x. We're not going to move right or left, but there is something outside of the function, which is a 4. 0, 4. And if you're struggling with that, that's when you might want to type in the calculator and go, oh yeah, that makes sense. Especially if you're taking a quiz or a test. Type it in. We're not taking the calculator out of your hands yet. When we look at the transformations, what this means is that we're going to go up 4. And then the other part here is there's a negative attached to that x inside the function. And that means that we're going to reflect the graph over the y-axis. So the thing is, remember, we can't always see the reflection across the y-axis on here. But when we start, let's start by graphing the vertex. Over 0, up 4. There's our vertex. Now, we're reflecting over the y. So we're not going to be able to see the change in this. But here's what happens. From this point, we're going to go 1 space to the right and 1 up. But what happens when we reflect it over the y is that point that we just graphed really lands right there. Again, flipping it over, so I'm twisting my hand to pretend like it's flipping over that y-axis. Watch again. From this green point here, I'll put that in green because that's where we're looking at. We're going to go 2 spaces to the right and 1, 2, 3, 4 up. So we would have a point here, except that we're going to reflect it over the y-axis. So on the other side of the y-axis, that point is going to land. Again, you can't see the change in this particular one, although I do have an example coming soon where we're going to be able to see the change. That's the graph of this particular problem. It's reflected. We can't see it on the paper, but it is. Letter C. Again, the vertex for some people is causing trouble. If this is a problem, then use your calculator now to help you. But our vertex on this one, we don't have anything attached to the x in terms of adding to x or subtracting to x. So it's going to be 0, 6. And if you're not sure, type it in your calculator and look at the picture. Can you identify what the vertex is from the picture? Or maybe you need to go to the table part of your graph. When we look at what's happening in this graph, we're going up 6. That's the plus 6. And then we have a negative in front of the function, which means that we're reflecting over the x-axis. And 0, 6. Start with the vertex. And once again, I'm making this hand gesture where I'm taking the graph and I'm flipping it over. I'm twisting my arm, flip it over. Sometimes when you use your hands to flip it over, it flips it over in your mind as well. So you need to know that this is an upside down quadratic. So when we're graphing the rest of this, we're going to go 1 space to the right, but instead of going 1 up, we're going to go 1 down. And from, I'll make it green again, from that point there, we're going 2 spaces to the right, but instead of 4 up, we're going to go 1, 2, 3, 4 down. This is reflecting it over. We're flipping it over. Same thing on the other side. 1 space to the left and 1 down. 2 spaces to the left and 4 down. And here's our picture. But as we finish here, it says the, oh, I can't see it there. Let me move this. Sometimes reflections are necessary after a graph has already been translated. Remember, translating means that we move it right, we move it left, we move it up, we move it down. And here are a couple of examples of those. If we take a look at this picture here for starters, it's the same graph on both of these. Our vertex is -2, 1, 2, 3, 4, 5, 6. -2, 6. And what we want to do is we want to write the vertex form of this graph. And just a quick reminder of vertex form, it is y equals a times x minus h squared plus k. That's the vertex form. So when we put this back in here, it's going to be y equals, and we're going to have something in parentheses squared. But the first thing is, our graph is flipped over. That means that we're going to have a negative in front of our function, because it's flipped over the x-axis. It's going to be x, well, our vertex is -2, so let's change sign. +2. Because the +2 is going to move us left 2. And then lastly, we have 6, which is up 6. Ask yourself when you draw this. When you look at it, is it left 2? Yes. Is it up 6? Yes. Maybe again you type this equation into your graphing part of your calculator and make sure that the equation matches with your picture on the graph. But what we're doing with these problems now is we want to figure out, we're given this graph, we want to draw a picture where we're reflected, ooh, got to spell it right, reflected over the x-axis. And again, maybe you want to use a different color, but what I'm going to start with is the vertex, which again the point is -2, 6. So if we reflect that over, we're going to be turning this graph the other direction. We went over to the right, over to the left 2, and we went up 6. We're going to go over to the left 2, and we're going to go down 6. One, 2, 3, 4, 5, 6. Again, if you use your hand gesture, you're taking this graph and you're flipping it over the x-axis. So you're turning it the other direction. So the vertex lands down here where that green point is. This point, -1, 5. We're going to flip it over the x-axis. It's going to become -1, +5. 0, 2. We're going to flip it over the x-axis. It's going to become 0, -2. The point 1, -3. We're going to flip it over the x-axis. It's going to become 1, +3. The point 3, 1, 2, 3, 4, 5, 3, -3, 5. It's going to become -3, -5. The point -4, 2 is going to become the point -4, -2. And lastly, the point -5, -3 is going to become -5, +3. And here's a picture of the reflection of the graph over the x-axis. Our new vertex is -2, -6. Going to do something similar to finish. only this time we're going to reflect it over the y-axis. I'm going to start with the vertex. And then it's all about counting. Our vertex, which is right here, when we reflect it over the y-axis, that orange point is 2 spaces away from the y-axis. On the other side, it's going to be 2 spaces away from the y-axis. Our point -1, 5 is 1 space away from the y-axis. So 1 space away from the y-axis on the other side. This point 0, 2 isn't going to move. It's going to stay on the y-axis. It was on the y-axis to start. It's going to stay on the y-axis. The point 1, -3 is going to flip over the y-axis. It's going to land right there. 1 space away. It was 1 space away from the y-axis on the right side. Now it's 1 space away from the left side. The point -3, 5 is going to be flip over the y-axis and land here at +3, 5. The point -4, 2 is going to flip over the y-axis and end up at +4, 2. The point -5, -3 is going to flip over the y-axis and land at +5, -3. And here we can actually see the reflection of a graph over the y-axis. And to finish, our new vertex is 2,